All right, we're going to go ahead and kick this example off, or this video off with an example very similar to the last example we did in video one. It wants us to find all these different trig functions based on this one diagram. So our angle in this particular case is this angle. That really doesn't change much. It still allows us to determine that our x value, which is going to be this root 2 over 2, or this x value right here, is the cosine of t. And just like before, the y value, which is this vertical distance, or negative root 2 over 2, is the sine of t. So these two functions, the sine and cosine, are always quickly determined by x and y, or the coordinates in our particular unit circle. So these values right here make these two trig functions very quick to find. In our last example, we did find the tangent, and actually I can go back and look at our notes. We found the tangent and the secant. So this time I'm going to look at just finding, I'm going to limit my work here to the cosecant and the cotangent. So the first function I'm going to find is the cosecant. The cosecant of t, we should know, is 1 divided by the sine of t. And as we just mentioned, the sine is y, so 1 divided by y, which makes our work 1 divided by negative root 2 over 2. Again, the sine right here is the same as y, and that's why we use that on the bottom of this particular expression. So just to simplify, we have to take the top, which is 1 over 1, times the reciprocal of the bottom, which is 2 over square root 2. And just remember that this is negative. We multiply, we get negative 2 over the square root of 2, but we must rationalize. We have to eliminate this radical on bottom. So we multiply top and bottom by the square root of 2. And we end up with negative 2 square root 2 over square root of 2, and the square root of 2 is the square root of 4, which is 2. Now, in this particular case, again, half of this is just simplifying radicals, simplifying roots. This part right here is important, but being able to simplify is equally important. So 2 over 2 cancels to 1. So our final answer for the cosecant of t is simply negative square root of 2. So that covers the cosecant. Looking at cotangent, I'm going to jump to cotangent. The cotangent of t we know is cosine of t divided by the sine of t, which in other words is x over y. Now, in this particular case, this is actually a pretty nice example. Our x value, excuse me there, our x value, oops, I don't know why it's not letting me go down here. Our x value is square root 2 over 2. That's from this x value. And our y value is negative root 2 over 2. And this simplifies very easy. We know in math that anything divided by itself, so we have the same thing here on top and bottom. Anything divided by itself reduces to 1. We do have a negative, so our final answer for cotangent would be negative 1. So between this example and the last example of video 1, we should have examples of how to find sine, cosine, tangent, cotangent, secant, and cosecant, our 6 trig functions. Our next example is going to ask us to really do the exact same thing. However, it's just basically reminding us that we are responsible for these values or these angles in the unit circle. So it's not giving us a picture necessarily. It's asking us to say, okay, we're in the unit circle, which is here. And we're at pi over 6. We have to recognize that pi over 6 is the same as 30 degrees. So we're really at this angle. And then we would need to go back to 7.3 to determine that our values here are the x value is the long leg, and that's the longer square root 3 over 2. And the y value is a short leg here, which is a half. And again, you could verify this using your unit circle. Hopefully you have a unit circle filled out. But really that's what this comes down to. So we know that our x and y values are those values based on our unit circle and less than 7.3. And now it wants us to find the sine, cosine, tangent, secant, cosecant, which again really just goes back to knowing all these ratios. The sine we already have. The sine of t is 1/2, it's your y value. The cosine of t is the x value, root 3 over 2. So those two are taken care of. Just kind of doing some random ones here. We could look at the tangent of t again. The tangent is going to be sine divided by cosine. Now it's important that you know it's sine over cosine and it's y over x. It's really both of these. You'll see me use or write this a lot because I really want you to make that connection. That tangent is sine over cosine is y over x. So in this case, we take our y value, which is 1/2, and we divide by our x value, which is root 3 over 2. Dividing fractions forces us to multiply by the reciprocal. So we flip this to 2 over square root 3. Once again, our 2's cancel. We end up with 1 over the square root of 3. We have to rationalize, so we multiply top and bottom by square root 3, and we end up with root 3 over 3. So this ratio right here is going to be your tangent. Again, we could go ahead and follow the same process for any other of these values. I'm going to go ahead and look at maybe just the cosecant. And again, just understanding that cosecant of t is 1 over the sine. And if it's 1 divided by the sine of t, the easiest way to do it is just to take that sine of t, which is 1/2, and flip it. So if I'm going to reciprocate here, 1 over sine, all it is 2 over 1, which is 2. That saves me a lot of work or hassle. So cosecant would be 2. Very similarly, we could do the secant. The secant of t is 1 over the cosine of t. And anytime you're doing 1 divided by, you can just flip the cosine. So the cosine value here is root 3 over 2. If I flip it, that's 2 over square root 3. We can't have a radical on bottom, so we multiply top and bottom by the square root of 3. And we end up with 2 root 3 over 3. Another good example of finding values of trig functions. Same concept. Obviously, when we're at pi over 3, we would need to go in and let me see if I saved some pictures. I don't know if I saved any of these. So here we could use our unit circle. I'm not going to go ahead and do this entirely. Oops. I'm just going to show you that we can use our unit circle to really help us with these problems. So if it wants us to find pi over 3, we go to our unit circle. That's this triangle right here. And identifying pi over 3 in this triangle is going to give us our cosine, which is the x value of 1/2, and our sine value, which is the y value of root 3 over 2. And then all of these other functions will be based off of that. Here is a table, and it's got those key values. So if you look at our unit circle, we've really spent a lot of time focusing in that first quadrant on 0, pi over 6, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And really all of these are our reference angles. Everything we do is going to be based off of these reference angles. So here is a chart that outlines all of these values we've talked about. You'll notice some common trends in here. We've talked about, obviously 1. We've talked about the square root of 3 over 2, square root of 2 over 2, a half, and 0 a lot. And now once we start getting to some of these other values, we've seen 3 over, root 3 over 3, the square root of 3. Some of these values start to repeat themselves as well. I would not recommend that you memorize this, but this could be a resource. This will really help you understand, why and where some of these values come from. So a lot of the values we will encounter as far as these 6 trig functions can be found in this table. Again, don't memorize it, but just use this as a point of reference or reforce, point of reference, no pun intended. Using reference angles to evaluate tangent, cosecant, cotangent. Before we get into this, this diagram just shows you the quadrants. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Make sure you know your quadrants, 1, 2, 3, 4. They go counterclockwise around the unit circle, starting with quadrant 1. This basically just shows us what trig functions are positive. So in quadrant 1, all of our functions are positive. That's important to know. So every single trig function in quadrant 1 is going to be positive. In quadrant 2, we only have 2 trig functions. The sine and the cosecant are positive. Just remember that sine and cosecant are very closely related. They're reciprocals. So if sine's positive, it's not a surprise that cosecant's positive. Down in quadrant 3, you have tangent and cotangent are both positive. Again, these two are reciprocal functions, so they should be related or have the same sign. And in quadrant 4, you have cosine and secant. Again, exactly the same concept. They're reciprocal functions, and these are positive. Now, you might say, well, why or how do you know that? Well, let's just go down in this quadrant and take a look at this for a second. And you could do this for any quadrant. If I was back this far and down this far, I'm going to have a negative x value and a negative y value. And think about tangent. We know that tangent is y divided by x. So if I do a negative y value divided by a negative x value, I'm going to end up with a positive. Very similar. Your secant or your cosine in this particular quadrant, we know that cosine is equivalent to just the x value. So in this particular quadrant, all of your x values, if I'm down here on this point, the only thing that's going to be positive is going to be my x value. You can see that to get there, I'm going to have to go positive x direction. My y value is going to be negative. So the only positive value in this quadrant would be the cosine. And there's a little acronym that helps you remember this. And actually, I haven't really seen this until we got this textbook, and I think it does a nice job. A smart trig class. So basically, in quadrant 1, all functions are positive. In quadrant 2, it's anything to do with your sine function, S-I-N-E. In quadrant 3, it's your tangent functions that are positive, tangent, cotangent. And in quadrant 4, it's your cosine functions that are positive. So a smart trig class will help you remember going counterclockwise around the circle that you have all positive. Here, sine, cosecant are positive. Here, tangent, cotangent are positive. And finally, C in class stands for cosine. So cosine and the secant, which is 1 over the cosine, are both positive. I'm going to stop there. Again, that's enough info. My video is getting plenty long here. I'm not trying to bore you. I just want to make sure that I give you some really good, thorough examples. Feel free to fast forward, pause as you need, but just remember that you are responsible for all this material.